Hey everyone, my name is Shane Robinson. I'm in the 7830 Advanced Research Seminar class, and this is our week 5 discussion post. So this is going over defending what statistical analysis we are planning to conduct with once we get our data after we complete our data collection phases of our dissertation, and just defending it. So just as a recap, my dissertation study is consisting of 3 arms, all comparison groups. There's no control group with this, but I'm investigating the optimal intensity of winter max resistance training for peripheral arterial disease. So I have a lightweight group, a moderate weight group, and then a heavyweight group. My outcome measures of interest are time to the onset of claudication in seconds for the low incremental cycling test I'm gonna have them perform, and also total time to exhaustion in the incremental cycling test. I will also have other outcome measures based off of ankle brachial index, and which is also another continuous measure. And then I also have muscle mass across sectional area and the size of the cross sectional area. So all these are continuous parametric values that I'm doing between the 3 groups. So ultimately I will do a pre and post dependent t-test just to determine each group, did they significantly improve. But then when I actually want to determine which group is optimal, I want to do a ANOVA, so analysis of variance between the 3 groups. And then that would also plan for me to do a post hoc analysis. So the difference between groups, I would plan on doing Tukey for my post hoc analysis, assuming just because my power analysis has shown me that I need 42 participants, so that'd be 14 each group. So ideally I'll have balanced groups with it. If I have dropouts or anything that I have to deal with unbalanced groups, I will probably do like a chef's post hoc analysis just to be able to deal with potentially maybe one group having more participants than others in the other 2 arms for that. That is from an overall comparison for my pre and post outcomes. Additionally, I have an 8-week intervention that's going over an autoregulation of volume. So that will require an autoregulation of how many reps an individual will complete before they hit threshold when they experience claudication, using a NIRS device. So I will have that and the time to recovery to get back towards resting values for their oxygen saturation as another component for the individual sessions that are doing a resistance training in. So what I would also like to do is a repeated measures ANOVA between sessions to determine if they are actually improving over time when it comes to these parameters. That is a good indicator for microvascular function based off of their mitochondrial density and capillary density, based off of how quick can they actually recover between each set when they hit that fatigue level. This will also help me look at different physiological limiters in that with their cardiovascular system. So I plan on doing that as well. And then another thing, just if I have time to be able to do something extra, there isn't much on optimal resistance training guidelines specifically for PAD. So I would like to do an exploratory analysis based off of how much volume can these individuals actually withstand within each given intensity range of a low, moderate, and high intensity. For it. So that is my analysis plans. The typical 95% confidence interval alpha levels, 5% for that. So my p-value for significance would be anything less than 0.05, just based off of what I did for my power calculations to determine that I needed 42 participants for my study. So let me know if you have any questions or feedback for this on this week's discussion post. Thank you.